Howdy everyone, welcome to the 4th episode of Devlogs. We'll be covering Lesson 3 of the WWise 301 certification, but before that, I wanted to share my status on a project that is now in the works for my asset implementation into Unity independent study. While diving into WWise rabbit holes through copious amounts of troubleshooting, I came across these demo reels that WWise users have made. I decided it would be a great idea to try making one of these and chose the Unity project for the game called 3D Game Kit. I have downloaded the game onto Unity with the 2021 version of WWise, and as of Monday, started the process of finding all the events for a specific scene in the project. The current problem I am experiencing is the triggers for either the sound bank or the event I created for the Growler game object. I am not sure which is responsible, but either way, my sound from WWise plays at the start of loading the scene. I messed around with the triggers, reapproached the lessons, and also looked into some error codes I've been getting regarding the sound banks not loading appropriately. I haven't solved my sound playing at the start of the game scene, but I did manage to get the events to show up in the profiler on WWise, which was another problem I had been having. I will be working on this later in the week if I have time, and if I make progress, we'll put a little something for you at the end of this video. However, I gotta shift priorities for this week and dive into Lesson 3, so let's get it. What we're getting into shall be sound bank management, managing sound banks in Unity, decompressing sound banks in Unity, and loading sound banks in Unity. Who knows, maybe this will solve the problem I am having with my sounds in the separate project. Okay, not to get my hopes up, but the beginning of this lesson seems to be approaching what I've been having trouble with. So, when we load scenes in Unity and run them, that scene is going to have game calls that call events to action based on what's happening in the game. In regards to events from WWise, this can be audio sources, audio objects, game syncs, and more. However, a game engine is not going to reference all of these things separately and will be looking for a single memory to search for these varying events. That's where sound banks come in, which store these different event types and are loaded at the beginning of a scene in Unity. If you're not following me, just hang on a little longer as we move forward in the lesson and I show some more visuals. We're going to load a sound bank into a scene and also discuss how to manage them, which is very important for making sure the audio events you've mapped to game objects function as intended. This is all determined by how you manage the sound bank. Real quickly before moving on, this blue box mentions the option of streaming an audio source rather than having it loaded into memory. WWise 101 talks about this, and the purpose of this would be for budgeting reasons. When you stream an audio source, you reduce the amount of assets loaded into memory, but the trade-off is that you're using more processing power. This is because of the game engine having to load a separate audio source that is being streamed, rather than it being a part of your memory. Having multiple sound banks is done in response to when big games have multiple levels. Different levels will and will not use assets from your WWise project as a whole. Because of this, we can create multiple sound banks with the appropriate assets stored in them that are used for a particular level. This prevents any unused assets from ever unnecessarily being loaded into a scene. This next part also mentions that sound banks don't only have to be loaded in accordance to the varying levels. You can also trigger sound banks to load in specific environments, like a forest or a desert. One could also load during specific quests that may play dialogue specific to that sole mission. No matter the reason, we can achieve this using trigger colliders. The collider tied to a player can come into contact with, let's say, a region collider, which then tells the game, oh hey, you should load the sound bank you have using the AK bank script, and it does exactly that. Now that we know how cool it is we can do that, we actually gotta set things up to happen. So behind this cube in the scene is a waterfall, which has a waterfall event for playing waterfall sounds. It is meant to only load into the game when the player is present in the woodlands area. When they're not in the region, this event should stop and the sound bank loaded in from memory should be unloaded and open up space for other sound bank instances. What now needs to happen for these things to happen is this cube needs to be turned into a collider that covers the woodlands area and loads the appropriate sound bank when its collider is triggered by the player. For the cube game object, we need to enable the isTrigger box. This makes the mesh of your collider one that can be entered and exited by the player. When we're playing the game, we want the mesh to be invisible, but for now, we'll make it transparent so that we can see our changes to the size. The cube is a little small right now, so we're gonna scale it. The lesson shows us where to equip the scale tool and instructs me to enlarge the box. The collider needs to cover the woodlands area, so I've stretched it above the trees, and you can see its edge stops right at the bridge the player would enter into the woodlands area. With our dimensions set nicely, the next thing to do is add an AK bank component to the woodlands trigger game object. Next is setting the load and unload properties on AK bank to AK enter and AK exit. With these properties set up, the collider will detect everything entering and exiting it. This is a problem because that includes any and all game objects that touch it. To fix this, we'll add the AK trigger enter component and set the trigger object in the inspector view to the main camera game object that you see in the scene view. We'll do the same thing for another component called AK trigger exit. This now makes it so the main camera, which follows the player around, will load and unload the woodlands sound bank for the woodlands trigger object that we tread in and out of. Further into the lesson, it talks about how separate events and scenes are also unnecessary to have loaded into the game when the player is not present in the area. In short, you can create your own scene that has a sound bank that loads with it once triggered, which contains sounds particular to that area, and the lesson shows you efficient ways of doing this. The lesson prompts some back and forth action between the WWise profiler and running your game in order to see this in the works. I won't show this on my Mac for performance reasons, but this part of the lesson shows this event management method very well. In the top right, you can see the profiler is set to listen to the waterfall event that was dropped into the scene I created. This scene is set to load into the game all events particular to the area covered by the mesh collider. If you remember earlier, this mesh collider is only checking for when the main camera enters the area, so you can see how when the camera is outside the area, despite the player being inside, the profiler does not pick up any loaded events. However, on the bottom pick, the camera has swiveled inside the area. Thus, you can see the event has loaded the scene containing the sound bank with events unique to the woodlands. If you're foggy on how the sound bank is being loaded, don't forget we're using the load scene async on enter component that we added in the inspector view for the woodlands trigger game object. After using the profiler to show off all of this, the lesson reminded me to turn off the filter in the profiler that is checking for the waterfall event to be loaded in. In the final section of the lesson, it talks about size budgeting in regards to the file size of audio assets. This passage breaks down sound bank size as well, saying the size of the sound bank solely depends on what audio format the audio sources are being converted into. Games have budgeting limits and can commonly be a reason for using a more compressed format on an audio format in order to reduce its size and meet the budget requirements for a game size. In WWise 101, WWise teaches us to use Vorbis, which significantly can reduce the size of an audio asset yet retain its quality in many cases. While this seems overall positive, the trade-off is that strain this puts on your CPU's processing power. A funny example that comes to my head comes from this article covering an interview by Richard Ledbetter for the game Titanfall 2. In this highlighted part of the article, it talks about how the developers chose to have 35 gigabytes of uncompressed audio in order for the CPU to have little strain handling unpacked audio files. This was done as a means of reducing latency in the game so that players would have a smoother experience playing their game. This passage here shows how the WWise methods of loading and unloading sound banks in accordance to when certain sounds are and are not needed can solve the problem Titanfall 2 devs were trying to avoid, which was the handling of too many audio files during runtime. Just in case you forgot what runtime is, that refers to the rendered platform-specific output from a Unity project. At this point, you might be weighing out which is better, processing power or the overall size of a game. A better thought would be finding an in-between, because truthfully, that sort of thing is a balancing act. However, this next part of the lesson pitches a really cool idea for keeping small file size, yet having uncompressed files during runtime. This can be done using the decode compressed data option, which is a pretty optimal method for having a smooth gaming experience whilst mitigating the amount of data being run when unnecessary. To start things off, we navigate to an AK bank component, checking off the decode compressed data checkbox. Keep in mind that you should have a sound bank that has been compressed if you are utilizing this method. The WWise 101 certification teaches about compressing files using Vorbis, which is an easy and effective compression method WWise is capable of. Checking that box will decode the compressed sound banks you see in this picture. You can see the size of the sound banks in the Sound Bank Manager picture. All of these are measured in bytes, and right next to the size in the highlighted boxed column, you could see what the size of those assets decoded would be. Before decoding the sound bank, the lesson has me open up a new scene in order to see the before and after changes in data size. In order to see the sizes, we have to move to WWise and open the profiler layout. Then we navigate to the advanced profiler view and click the memory tab. While the profiler is running, we have to enter and exit play mode in Unity for the profiler to monitor changes in what's loaded and unloaded into the scene. If you look back into the memory tab and under the peak viewed column, you can see the peak values of data usage for all profiled objects, including sound banks. The dungeon sound bank peaked at 2.4 megabytes. Since we loaded a new scene, we have to recheck the decode compressed data box for the sound bank. This is located in the WWise game object's akbank script in the inspector view. When we do this, a warning message pops up telling us we need to prepare the pool size in the WWise initialization settings. The box will still be checked, but this message brings us to the next step, which is defining the size of your data that is being decoded in the prepare pool. This is found and provided in the AK Initializer component's initialization settings. The needed component is already in the WWise Initializer game object for this scene. When we click it, the AK Initializer script is in the inspector view with the initialization settings we are looking for. You can see in the Soundbank Manager that the decoded size of the dungeon soundbank is almost 10 million bytes, which means we should make the pool size 10 million bytes. The lesson says we might have to apply these settings by entering and exiting play mode. After doing this, we can go back to the advanced profiler to check the size of the prepare pool. If you had monitored the prepare pool's size beforehand, you'd notice its size has increased because of the dungeon soundbank being added into it. The dungeon soundbank is also no longer present because of it being in the prepare pool. If you're not seeing the numbers shown in the picture, it's because you exited play mode. After you've seen these changes, you can exit play mode and head back to the WWise initialization settings. Since we added the soundbank that we wanted to avoid resources on for decoding, we now have a final byte size value for the pool size that we need to accommodate for in the initialization settings. The used pool size was 8.4 megabytes, so WWise suggests setting the size to 9 million bytes in order to leave some wiggle room. Our memory usage in this scenario will be higher, but that usage will be unpacked at a necessary time, improving the CPU's all-around performance in the scene because the assets are only being used when needed. So that part of the lesson showed us how to reduce file size for budgeting reasons, whilst allowing the CPU to perform as best as possible. This final part of the lesson brings up the question, what if the budget allows for much more file size? At that point, you can use the Save Decoded Soundbanks method, which ignores decompressing files and pulls straight from a saved, decoded one. This is quicker, takes more space, but is less strain on the CPU. The lesson has us load another scene for saving a decoded soundbank. Before getting into Unity, the lesson has us pull up the directory for a soundbank in WWise that we are wanting to save. This will let us visually see what happens when we save a decoded soundbank and where it is stored. It has me navigate to the soundbank layout in WWise, and when right-clicking on a soundbank, can click Open Containing Folder. I'll do as the lesson did and click the Dungeon.bank option, which opens up the File Explorer and shows exactly where that soundbank is in your WWise project folder. We're fully set up to see the change, so we can now move to Unity. In the WWise game object, there is an akbank component in the inspector view. This time, we will enable the Save Decoded Bank checkbox. When we enter play mode and exit it, we can go into the Generated Soundbanks folder where you'll see a Decoded Banks folder. This has the dungeon soundbank that we wanted to save. This means it is no longer in the memory pool. If you were to look in the Advanced Profiler under the Memory tab in WWise, you'd see the dungeon soundbank is loaded separate from the memory pool. It never had to be decompressed, which puts less strain on the CPU. That is the end of Lesson 3. I mentioned potentially showing footage of my progress for the demo reel project with the 3D Game Kit game. What I found was that I have chosen incorrect load and unload properties for certain components. I also may not be using the correct audio kinetic components, I think, but it's hard to determine what my problems seem to be because of not having completed all the lessons in this certification. There might be a component I am forgetting to use or haven't learned to use yet that will solve my current problem, which is getting the sound I made for a growler to play when it attacks. It's also time consuming to run tests because I have to navigate to the growler I made the component and audio event for. I wanted to mess with the footsteps instead, but could not find out what parts of the character game object contain the walking event that I would need to name my audio event in Wise. I am either going to reach out for help online or continue troubleshooting. Regardless, hopefully I got something to show for it next week. The biggest thing to keep in mind at this time is that there are bound to be many problems I troubleshoot during my initial strides trying to use Wise with Unity. Despite what feels like little progress, it'll be refreshing to hopefully have something to show y'all soon, and once I do, it should become easier to set things up next time. Thanks for listening. I'll see you in the next video. Have a good one.